Hello class, today we're going to be going over lesson 5.1, how to write two-step equations. So the first thing we want to know is what is the definition of an equation. So an equation is a statement where two values of a math expression are equal, and there must always be an equal sign in between these two expressions. So if we look here at our example, we could see 3x plus 5 equals 8. The key important thing in here is we have two expressions, 3x plus 5, and then 8 is also an expression, and then we have this equal sign in between them. So what this is telling us is that for some value x, or some value we don't know yet, it could be anything, 3 times that value plus 5 will equal to 8. Now we're going to learn about solving this in the future, but for now we just need to learn how to write it. So one of the important things we need to remember are the properties of equality. So the properties of equality tell us that whatever we do on one side of the equation, we must also do on the other side of the equation. So basically, we want to think about our equal sign as like the middle of a seesaw. So if we got a line right here, this would be our seesaw, right? This is basically our equal sign right here, right in the middle. Now on one side of the equation, we could have on one side of the seesaw, we have the left side of our equation, and on the other side, we have the right. So to keep this seesaw balanced, whatever we do to the left side of the equation, we also have to do to the right side of the equation. So for example, I was to subtract a 5. If I just subtracted the 5 off the left side, then we would have 3x. But this would be unbalanced, right? Because we didn't subtract it from the other side as well. And let's remember, it was only balanced when 3x plus 5 was equal to 8. So to correct this, we're going to have to subtract a 5 from the other side of the equation as well. So now we will do minus 5 from here. So 3x will be equal to, and then 8 minus 5 would be equal to 3. And then this will be our seesaw right here. And again, it is balanced because we did what we did to each side of the equation. All right, we'll get a little bit more into how to solve these in the next section. But for now, I just want you guys to know that we have to keep that seesaw equal, or that equation equal, when we are working with it. So our key concept today, an equation shows a relationship between the variables, the coefficient, and the constant. This relationship allows you to write equations with 2 or more steps, or to write equations that use more than one operation. And we're going to start doing that now. So here's our first example. Marley collects golf balls. His neighbor Tucker collects 3 more than twice as many golf balls as Marley. Create a table to represent the number of golf balls Marley and Tucker have, depending on how many Marley collects. Alright, so first thing we want to look off is how many Marley has. Well, let's say Marley starts off by collecting one golf ball. Well, Tucker collects 3 more than twice as many golf balls as Marley. So, you'll have twice as many times Marley, which would be 2 times 1. And then we're going to add 3 to that, because it's 3 more than twice. So 2 times 1 is obviously 2, and then plus 3 will equal 5. So when Marley collects 1 golf ball, Tucker would collect 5. All right, what if Marley collects 2 golf balls? Well, if Marley collects 2 golf balls, then it would be 2 times more than 2. And again, we're going to add 3. So here 2 times 2 is 4, and then adding 3 would be equal to 7. So if Marley collects 2 golf balls, then Tucker would collect 7. All right, now how about 10 golf balls? What if Marley collects 10? All right, well, they would have 2 times 10, right, because they have twice as many than Marley collected, plus 3. So 2 times 10 would be 20, and plus 3 would be 23. So when Marley collects 10, Tucker would collect 23. Now lastly, what if Marley just collects an M number of golf balls, right? We'll do an M from Marley. Then Tucker would collect 2 times M, and we're still going to be adding 3 here. Now we don't know what this is yet, but that would be our expression, 2 times M plus 3. So how could we write an algebraic expression to represent the number of golf balls Tucker has? All right, well, we're actually going to write an equation on this one here. So last slide, we said Tucker would have 2 times M plus 3, where M is equal to the number of golf balls Marley has collected. In order to make this an equation and an set of expression, we need to have an equal sign in there. All right, now what did we say 2 times M plus 3 was? Well, 2 times M plus 3 was the number of golf balls Tucker collected, right? So I'm just going to put a little T here, where T is Tucker's golf balls, and M is Marley's. right? So 2 times m plus 3 is equal to t would represent our equation for how many golf balls Tucker has collected based off how many golf balls Marley has collected. All right, so this next question here tells us if Tucker has 159 golf balls, what equation can we write to compare Marley's collection to Tucker's? All right, well, we already set up an equation for how many golf balls Tucker has, right? We said that was t. So now we just need to plug in the 159 for t. All right, so we would still have the 2 times m plus 3, where m's the number of golf balls Marley has, and then we're going to set that equal to 159, because that's what they told us how many golf balls Tucker has. All right, so that's an equation for us. And remember, this is like a seesaw here, right? So if we put our little line under it, whatever we do to the left side of the equation has to happen to the right, because currently this is balanced here. All right, we'll get working to solving these in the next chapter, but for right now, I just want you guys to be able to set them up. All right, next question here. Claire bought 8 tickets for a total cost of $104. She used a coupon code to get $3 off of each ticket. Let X be the original cost of each ticket, and we want to write an equation to represent the situation. All right, so she bought 8 tickets, right? So we have 8 total. 1, 2, 3, 4, 5, 6, 7, 8. All right, let's just assume these are denoting how much money we have in them here as well. And she said they got $3 off each ticket, right? So basically, a little bit of this they didn't have to pay for on each ticket. Now, we don't know how much each ticket costs yet, but we just know that each ticket was $3 left based off our coupon. All right, so we have 8 of these here, right? So we're going to have an 8 times x. But is this a regular x? It's not, right? Because x is the original cost of the ticket, but she's getting $3 off each ticket. So this is actually going to be 8 times x minus 3. 8 times x minus 3, where x is the original cost of the ticket, and remember, she's getting $3 off each ticket. So with all of these devalued tickets here, she has 8 of them, and what is that going to be equal to? Well, she spent $104. So we want to make sure we get an equal sign here, and equal to 104. Because she spent $104 total. Now again, tomorrow we're going to learn how to solve this, and hopefully you guys have already seen that in the past. But now we just need to learn how to set it up. All right, Jordan wrote the following description. 3 fewer than 1/4 of x is equal to 12. And we want to write an expression to represent the situation. All right, so again, 3 fewer than 1/4 of x is equal to 12. So we have 1/4 of x. I'm just going to write that first. 1/4 of x. And then what are we doing to that? Well, 3 fewer. 3 fewer is the same as saying we're subtracting 3 from it, right? So 1/4 times x minus 3 is 12. Is equal to, is 12, same thing here. So we're going to set up an equal sign and 12. Now again, right now this equation is balanced, so if we were to solve it, we would have had to make sure to do what we do on the left side, also to the right side. But for now, we're just setting it up, and 3 fewer than 1/4 x is 12 is the same as writing 1/4 times x minus 3 equals 12. All right, last one for us here. Mia buys 4 1/5 pounds of plums. The total cost after using a coupon for 55 cents off her entire purchase was $3.23. If C represents the total cost of the plums in dollar per pound, what equation could represent the situation? All right. First off, I'm just going to change this 4 1/5 to 4.20, just its decimal form. It's going to be a little bit easier to work with here since we're already working with cents. All right, so again, this is 4.20 pounds of plum, and with C represents the cost of plums in dollar per pound. So we want to find, it's 4.20, and then C represents the total cost in plums, so times C, right? Because that will tell us how many plums she bought. All right, now again, so you said she used a coupon for 55 cents off her entire purchase. That basically just means that we're going to need to subtract 55 cents from whatever she is spending on the plums, which is this value right here. And then her entire purchase total was $3.23. So 4.2 times C minus 0.55 is equal to $3.23. Alrighty, everybody, that was quickly some examples for us on writing two-step algebraic equations. Today we talked about an equation. Remember, an equation is a math sentence where two expressions are equal to one another. And we know about using our properties of equality, which tells us that what we do on the left side of the equation, we also have to do on the right side. Finally, we saw a few examples of writing equations to represent situations. We're going to be doing this a lot in the future, so hopefully we're going to start getting used to seeing these equations. Hopefully this was helpful to all you guys. Be sure to ask those questions in class tomorrow. I'll see you guys then. Bye-bye, everybody.